Okay, welcome to video 4. I would say of all the skills that you need to be able to do, this one is probably by far the most important. When I was at the conference, I would say we did this every day, this skill right here. You have to be able to do this skill in your sleep, without even thinking about it. We did chemistry at the conference for 10 hours a day for 10 straight days, and there was a weekend in between. But it was intense, and you need to be able to do this skill. So we learned in honors chemistry that whenever you have a mole of something, you have 6.2 times 10 to the 23 of it, just like when you have a dozen, you have 12. Okay, that's a lot of, so if you have 6.02 times 10 to the 23, let's say atoms of carbon, okay, or any atoms of calcium, atoms of sodium, you have a mole of it. Okay, now, you need to be able to know how to get a mole of a compound, okay? And a mole of a compound, okay, is equal to, okay, its molecular weight in grams, or if it's you could say, or its atomic weight, okay, in grams. And you get those masses, okay, from the periodic table. Okay, and again, this is called, by the way, molar mass. Okay, when you're getting a mole of something by adding up the masses on the periodic table, this is called the molar mass. Okay, so you have to be able to convert from moles to grams and grams to moles. Okay, so here they want us to convert 1.50 moles of mercury to phosphate 2 grams. So the first thing you always do is put what's given to you, moles of Hg3PO42 over 1. Okay. The next step, okay, is to calculate the molar mass of this. Okay. So you need to then go to a periodic table, which I have right here, and this is the AP periodic table, okay, and use the masses here. Notice that oxygen is not 15.99 on this periodic table. They round it to 16, so we'll no longer be using 15.999. Okay, so if we look at that formula, the first thing, and I'm not going to write this out, I'm going to talk through it, but you should probably do it as I'm doing it. So we have the formula, which I wonder if I can write on here. Yeah, I can. Look at that. 3PO42. Okay. So that was the formula. And we need to get the molar mass of that. So we need to find mercury. Here's mercury. And mercury's molar mass is 200.59. Okay. And there's 3 of them. Actually write it out. So what you're going to take this and multiply it by 3. Because there's 3 of them. Okay, and then for phosphate, there's 1, but this multiplies in, so that means there's 2 phosphates. So you take the mass of phosphate, which is 30.97, right, phosphate, yeah, and multiply it by 2. And then oxygens, 2 times 4 is 8, and 16 times 8. So you can do all those multiplications and add them up. I'm going to do it now. Can't button press correct. Make sure you button press right. Times 3 plus parentheses 30.97 times 2 plus 16 times 8 is going to be really high. And hopefully I did this right. If not, someone will email me and correct me if I button press wrong. That's the molar mass. Very, very high molar mass. Almost, because mercury is so heavy. Okay. So now that you got that molar mass, which I'm going to write down because I'm going to go to another screen. Alright, you go back to our problem that we were doing. And you know, remember, we use conversion factors. 1 mole is of this crazy compound is equal to 791.71 grams. Okay, moles cancel. And this is telling you that you have to multiply. So this times 1.5, this times this, is a very, very large number. Okay. Now, although this is kind of weird, okay, if we go back, and again, I don't know, usually the numbers work out better. We need to consider Sig Figs here. So, this has 3 Sig Figs. Our mass only had 5, so our answer can only have 3 if we're doing this correctly, which it would be this then, 90 grams, if we're looking at Sig Figs that way. Because remember, 1, 2, 3 Sig Figs, this 7 rounds to 9, and then the 0 there, that has 3 Sig Figs. Okay? Now, in reality, you can really just memorize that when you're converting from moles to grams, what do? You get the molar mass and you multiply. Okay, you can really just do that. I mean, I feel like when I'm doing that, most of the time, like I just don't write it out and multiply it. But again, on the AP exam, you need to show your molar masses. Okay, so now we're going the other way. We're given grams, okay, and they got to give us moles. All right. So 3.50 grams of Rb2S over 1. Alright? Now, in this problem, grams is on top, so the molar mass is going to go on the bottom, and then 1 mole is going to go on the top. We got to get the molar mass of Rb2S, which I will do. I'm not going to show you this time. You can be doing it while I'm doing it. So Rb is 54.7, and there's 447, right? Yep. And there's 2 of them. And then sulfur is 32.06. That one I memorized. And I messed up. You can't button press in the summer. And we get, oh wow, nice number, 203. How could that be possible? Let me do that again. How could it be? It's never a nice number. Plus 2 times 85.47. Yeah? Okay. Now in this case, grams is going to cancel. And now we're going to divide. 3.50 divided by 203. Okay, 0.017241379. Okay, now one thing that's true, when we did this in chemistry, and you were calculating moles, usually it was like a whole number, or like a 0.5. That's not going to happen. We're going to have all these like annoying decimals of moles. So now we need to worry about Sig Figs. This has 3 Sig Figs, and this also has 3 Sig Figs. So our answer needs to have 3 Sigs. The first 0 doesn't count. Remember, it's a leading 0, and then 1, 2, 3. So 172 moles. Okay. Now, they could also ask, okay, they could ask you to take this moles and convert it to formula units, okay? Or if this was like a molecule, if it was like carbon dioxide, convert it to molecules. If they ask that, then you take the number of moles and multiply it by 6.02 times 10 to the 23. Okay, this problem didn't ask that, but they could ask you to say, okay, well, you have this many moles of this compound. Okay, how many, when it's an ionic compound, it's called formula units, and when it's a covalent compound, it's called molecules. Okay, but they could ask you how many of that. The other thing that they could ask you, okay, which we didn't really do this at all in chem, and it was a bonus on one of the tests at the end of the year, okay, is they could ask you how many ions, how many sulfur ions do you have, or how many rubidium, so sulfur ions, or how many rubidium ions do you have, okay? Well, if you look at this formula, there's only one, how many moles, we're not going to talk about the number, how many moles of sulfur ions do you have? Well, there's only one, so in this case, the moles of sulfur ions are going to be the same. Okay? But in this compound, there are 2 moles of rubidium, because of this 2. So to get the rubidium ions, you would need to multiply this by 2 to get the answer. I know we didn't really do that, and that might be difficult. I think there's one question on the summer assignment that's like that. But again, I'll say it again. Because, so you calculated the number of moles of this, okay? There's only one sulfur in the compound, so the number of sulfide ions is the same as this number, okay? But to get the number of rubidium ions, you have to multiply this by 2. Also remember that this formula is composed of 2 of these, 2 Rb with Rb plus 1 ions, and then 1 sulfur ion with a minus 2 charge. That's what that compound is composed of, and that dissolves in water. So you would have that in water. All right, I have one more video left. See you in
August.